Welcome back. In the last video that was actually on topic, we got two of these A1335 Hall effect angle sensors up and running. Card here, link in the description. We tested the whole thing using a freely rotating Lego wheel here with a magnet attached here in the center. And that jig was a leftover from a series of videos about the A1334 Hall effect angle sensor. At least one card here, many more links in the description. Of course, that jig won't do it anymore. First, it only sports one rotating magnet, and now we have two sensors, so we do need two rotating magnets. Second, it's based on a freewheeling wheel, which has some drawbacks. First, it's freewheeling. That is, if you try to set it to a position, it probably won't stay there. Yeah, the slightest touch and it rotates out of position. So I want to have some friction here on the axle, so I actually need some force to turn it. And that friction can't be of the rubbery type, which I produce here with my finger, because that would probably imply that there is some backlash, and I don't want that. So I need some static pressure friction here. Second, in the old model, the zero position was achieved by turning the tooth with a red marker to the top. That's also not very precise and very repeatable. So I want to have a real mechanical precision, repeatable zero position here somehow. So let's see if we can fulfill all these requirements with some LEGO Technic jig. Enjoy! The basics. We have an axle, and at one end we have either a wheel to turn it, or maybe some kind of lever. Yeah, we're flexible there. And on the other side we have to attach our magnet, and I found these little parts here. And my magnet should perfectly fit inside it once we remove that rubbery stuff here at the center. And gone. The magnet almost fits, but not quite. Maybe we need to take a few tenths off here. Millimeters, of course. Anyway, we now have, hopefully, a method for attaching a magnet to one side of the axle. So let's have a look at the other side, where a wheel for turning or a lever for turning will go. After the wheel, respectively lever, we need some bearing, okay, and now we need to apply some pressure on the axle, which is not possible to do directly because the axle is a cruciform and that wouldn't give us a really smooth motion, would it now? The smallest parts I found to do that are these micro pulleys. Yeah, they are intended for rubber bands. And if we slide two of them just here on our axle, we get a nice smooth surface here, which, we can apply some pressure on. But how? One possibility would be to use these shock absorbers with a spring, and there's a very nice thing about those. If you attach them like that, so one pin through here and then a plate on the bottom and a plate on the top, there is absolutely no play and they still can move freely. Great! So we can use these very conveniently here to apply some force on our axle to create friction. And it does work, okay? It's no longer freewheeling, but it's not a whole lot of friction. Maybe we can do a little bit better. I've replaced the two micro pulleys with a small wheel here, without the tire of course. This has two advantages. First of all, the spring is more compressed, so we apply more force here and get more friction. And that friction force is acting on a longer lever on our axle. So I have to apply now a whole lot more force to turn it. Now, I need a second bearing for the axle here, otherwise it will be pressed into that direction by the force of the spring. And I also want a second bearing here on the other side of the spring. So I exchanged that 2 long pin with a 3 long pin. And we simply build up the stuff here a little bit and attach that part. And we should be golden. Oh yeah, this is very hard to turn now. Very hard to turn. Maybe a little bit too hard to turn. Yeah, let me think about that. Okay, I just moved the pin for the spring 1 hole back. That relieves a little bit of the pressure. We still have here enough friction. And now we should be able to assemble that whole thing without coming it apart. Yeah, wonderful. I thought about how we could implement that mechanical zero position so that you can feel some kind of detent action at one position. And the only thing I could come up with was adding another wheel here, maybe not exactly that wheel, and another spring. The wheel would need to have a little notch here, which the spring could latch into, and that would give us our zero position. Unfortunately, I didn't find any Lego part that fits the bill. So I might end up changing a bit such a wheel and just milling a notch into it. I built another little Lego jig to hold that wheel inside a vise, and I aligned that using the stop here with the center of my drill press, and I think it's pretty spot on. The little drill bit I used for aligning is gone, and now I have in here a 6mm milling bit, and yeah, wish me luck. I think that doesn't look too shabby, does it now? Let's do a second wheel for the second magnet on the other side too. I also carved away with a knife at the inside here of our little pulley at the other end of the axle, so the magnet would be a really snug fit in here. And I won't show you the process because it involved a very sharp knife and some people would probably consider it as dangerous. After that brief machining intermezzo, let's continue with the build. So I have here my wheel with the notch and I have here my spring and okay, not gonna work. Let's try if that looks like if I put the spring into the next notch. Oh, that's too much force. That's far too much force. That's the same problem we encountered here. But if the spring would just, you know, not be fixed with a pin, but instead hold in place here by something else. Let me think about that. Okay, one step back. I removed that long bar here that provided our second bearing and we replaced that by a shorter one. Okay, and then I discovered these parts in my collection, which would give us an offset of exactly half a hole, and maybe, just maybe, that's enough to relieve the tension a bit, so the whole thing works. Our notched wheel again. And our spring. And yeah, that already feels good. That already feels good. Yeah, that's working like a charm. Now let's add a second bar here on the end as a third bearing for our axle. Okay, and then we have to attach one of these pieces here and fill up the holes and we're basically done. Yeah, the magnet of course goes here. And of course the axle is too long. I'll get a shorter one. Unfortunately, the next shorter axles I have are too short. So let's instead beef it up here on that side and bring the total width to 6. And I also added here another 3 long pin inside to, yeah, give that a little bit more stability. And now we can cover that up from the top. Let me get some plates. So yeah, this will be very colorful, but from what I gather, that's the way modern LEGO Technic models are built. Very colorful. Yeah. Nothing you can really do about that, I guess. Okay, now for the back side. Of course we fill in the holes here with some blue, because yeah, that's what I grabbed out of the box. And then how did we do that? Yeah, these 6x4 plates here, 6x1 here at the end. 6x4, and then the rest. That is, here at the bottom we should probably cover up these areas too, huh? Now I can't, or I think I can't put a plate here. Is that working? Yeah, that's actually working. It's still spinning, so to give that some real heft, we can take such a really big plate and put it onto the bottom. Yeah, perfect. Really smooth action, and here you can see it. Snap into 0 position. Very nice. Okay, now the next problem. The magnet, which I forgot to attach, has of course to match the height of my sensor. I fiddled around a bit and came up with that setup here. So here's our black base plate we placed last, and that sits now on a full height block on another base plate. And on that base plate we have a piece that is flat on top, and on that our breadboard rests. And that brings up our sensor to approximately the height of our axle. So I created a nice flat area here on 2 very old base plates, oops, for the breadboard. And I also have, these parts here, and they will hold actually a frame. And I fiddled around a lot with that frame. So obviously one side here is floating, the other is also affixed to the base plates. And this will actually hold the breadboard quite snugly. So yeah, there is no wiggling here. That is really snapped in. These 2 axles here hold the 2 bars together and clamp the whole thing in, but also they apply some force here from these ends. And if you look closely, you see here 2 very short connectors, as spacers, because on that side of the breadboard there are some knobs for attaching the power rails. So yeah, a nice solution. And of course on one side, there's a millimeter missing also. So the air gap here to our second jig will be a little bit greater. But as we have seen in the videos about the A1334, I already covered them. They are all linked in the description. These sensors can handle quite large air gaps. Anyways, I have a really big problem now. You see the jig with the magnet is no longer fitting here because it collides at the bottom with that axle. So I need more space, and I will have to remove that nice big black backplate. By the way, I also optimized that whole thing here, the frame, so also in the horizontal, the sensor will be perfectly aligned with the magnet. I removed the big black base plate off camera because that is really, or was really, a pain in the behind. I reattached my normal Lego blocks here, and I added in between another layer of plates, so I will end up at the same height again. Now all that's left to do is to place my magnet rotating jig here on the base plate, and we're done. Well, almost. I need to build a second one of those. And here it is. Well, not as colorful as the first one. Oh, I just noticed. That's the German flag. Black, red, gold. That happened by chance, believe me. Anyways, we have now a perfect test jig for 2 A1335 precision Hall effect angle sensors. And so we can continue in the series, or start the series, the details about the A1335. But Robert, you might ask, where is all this leading to? I'll give you a hint. Vroom, vroom.